Hello, in this lecture we will find out the value of angle ADC using two different methods. In the drawing we have triangle ABC. We know that angle ABC, this angle equals to 30 degrees. Angle ACB, this angle equals to 100 degrees. We also know that side AD equals to side BC. And we want to find out the value of this angle ADC. So we'll start with the first method. In the first method, we will define side AC of triangle ABC as A, that is to say it equals to A units in its length. And we will define side BC of triangle ABC as B, that is to say it equals to B units in its length. According to what is given us in the question, we know that AD equals to BC. AD equals to BC. But according to our definition, BC equals to B units. So from this equation, AD equals to BC equals to B, we will derive that AD also equals to B. So we can write here that AD equals to B. And in the next step, I will present to you a new law that is actually the law of sines. The law of sines is true in any triangle. So you can write down that in any triangle, so if you have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side BC of triangle ABC equals to A units in its length. This is angle A. Side AC of triangle ABC equals to B units in its length. And this is angle B. And side BC, side AB, this side of triangle ABC equals to C units in its length. And this is angle C. Then, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. And it is so in any triangle. I will repeat again, according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. From this formula we will derive that A over sine A equals to B over sine B. Okay. In the next step, I will copy triangle ABC in a new page, and we will implement the law of sines in this triangle ABC. So this is triangle ABC that I copied from the original drawing. We know that AC equals to A units, BC equals to B units, angle ABC equals to 30 degrees, and angle ACB equals to 100 degrees. We will find out the value of the missing angle. We will define this angle as angle X, angle CAB equals to X, and we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle ABC, X plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we will subtract 130 degrees from this equation, and we will get that angle X equals to 180 degrees minus 130 degrees. That is to say, angle X equals to 50 degrees. So this angle equals to 50 degrees. In the next step, we will implement the law of sines in this triangle ABC. According to the law of sines, we will get that A over sine 30 degrees equals to B over sine 50 degrees. Okay, here we will divide the equation number 1 by B, and then we will multiply it by sine 30 degrees, and we will get that A over B, according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. Okay. In the next step, we'll focus on triangle ADC. Actually, we just right now found out that angle BAC, this angle equals to 50 degrees. So if we define angle BAD as angle theta, then angle DAC, this angle will be equal to 50 degrees minus theta. And we will define the angle that we are looking for. Angle ADC is Y, and we know that the sum of the angles in triangle ADC must be equal to 180 degrees. So angle Y plus 100 degrees plus 50 degrees minus theta must be equal to 180 degrees. Here we will subtract 150 degrees from this equation, and we will get that Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. Here we will add theta to this equation, and we will get that angle Y equals to 30 degrees plus theta. So the angle that we are looking for, angle ADC, this angle equals to 30 degrees plus theta. So I write it down. This angle equals to 30 degrees plus theta. In the next step, I will copy triangle ADC in a new page, and we will implement the law of sines in this triangle ADC. So this is triangle ADC that I copied from the original drawing. We know that this angle is 30 degrees plus theta. This angle ACD equals to 100 degrees, and angle DAC, this angle equals to 50 degrees minus theta. So we will implement the law of sines in this triangle ABC. According to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees Here we will divide equation number 2 by b, and then we will multiply it by sinus 30 degrees plus theta, and we will get that according to equation number 2, a over b equals to sinus 30 degrees plus theta over sinus 100 degrees. Okay, this is according to equation number 2, but we have already found out that according to equation number 1, a over b equals to sinus 30 degrees over sinus 50 degrees. So we will create equation number 3 that states that a over b according to equation number 1 equals to a over b according to equation number 2. So according to equation number 3, we will get that a over b according to equation number 1 is sinus 30 degrees over sinus 50 degrees. And it equals to a over b according to equation number 2, that is to say it equals to sinus 30 degrees plus theta over sinus 100 degrees. So here we will cross multiply equation number 3, and we will get that according to equation number 3, first of all sinus 30 degrees is 1 over 2. So 1 over 2 times sine 100 degrees will be equal to sine 50 degrees times sine 30 degrees plus theta we will use the trigonometric identity that sinus 2a equals to 2 sine a cosine a. In order to calculate the value of sine 100 degrees. So sine 100 degrees will be equal, according to this trigonometric identity, to 2 sine 50 degrees times cosine 50 degrees, and it equals to sine 50 degrees times sine 30 degrees plus theta. Here 2 over 2 is 1, so 2 will get cancelled. And we have sine 50 degrees on both sides of equation number 3, so sine 50 degrees will get cancelled. And we left only with cosine 50 degrees that equals to sine 30 degrees plus theta. Here we will use the trigonometric identity that cosine alpha equals to 90 degrees equals to sine 90 degrees minus alpha, and we will use this trigonometric identity in order to find out the value of cosine 50 degrees. According to this trigonometric identity, the value of cosine 50 degrees will be equal to sine 90 degrees minus alpha. It is, alpha is 50 degrees, so it is 90 degrees minus 50 degrees. So we found out that cosine 50 degrees equals to sine 90 degrees minus 50 degrees is 40 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees because it equals to sine 40 degrees. So we'll do it now, and we will get that sine 40 degrees equals to sine 30 degrees plus theta. So sine 40 degrees equals to sine 30 degrees plus theta means that 40 degrees equals to 30 degrees plus theta. Here we'll subtract 30 degrees from this equation, and we will get that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. So we actually found out that angle theta equals to 10 degrees, but the angle that we are looking for, that is actually angle ADC, equals to 30 degrees plus theta. That is to say, it equals to 30 degrees plus 10 degrees, that is actually 40 degrees. So we actually found out that the angle that we are looking for, that is actually angle ADC, equals to 40 degrees. We finished with the first method. In the next step, I will present to you how to find out the value of angle X according to the second method. In the second method, we will define side BC as A. That is to say, the length of side BC is equal to A units. And according to what is given as the question, we know that AD equals to BC. But according to our definition, BC equals to A. And from this equation, AD equals to BC equals to A, we will derive that AD equals to A. So we can actually didn't draw the side AD, so we'll do it now. Side AD This is side AD. And according to what is given us in the question, AD equals to BC, but according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD equals to also to A. So here side AD equals to A units. In the next step, we will extend side BC by a straight line and from point A we will draw perpendicular to the extended BC. So actually this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. In the next step we will find out the value of this angle that we will define as angle Y. We know that BC is one side of triangle ABC, therefore it is absolutely a straight line. And when we extended the straight line BC by a straight line, it will be still a straight line. Here we will define the intersection point between the extended BC and between the perpendicular from point A is point E. So here we know that BC is the straight line and we extended the straight line BC by a straight line, therefore we got line segment BE that it also must be a straight line. So we know that BE is a straight line. BE is a straight line. Line segment BE is a straight line. And we have the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BE at point C, then the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of the straight line B at point C? We have 100 degrees plus Y. So according to the rule that I mentioned, 100 degrees plus the size of angle Y must be equal to 180 degrees. Here we will subtract from this equation 100 degrees and we will get that angle Y equals to 180 degrees minus 100 degrees, it equals to 80 degrees. So we found out that angle Y equals to 80 degrees, so we can write here that angle Y equals to 80 degrees. In the next step we will define side AE as Y and we will define line segment CE or side EE as X. That is to say, line segment CE equals to X units in its length and line segment AE equals to Y units in its length. In the next step we will focus on the right triangle, triangle AEC. On the right triangle, triangle AEC, we know that tangents 80 degrees equals to AE over CE. I will repeat again. On the right triangle, triangle AEC, we know that tangents 80 degrees equals to AE over CE. But according to our definition, AE equals to Y and CE equals to X. Therefore, we actually will get that tangent 80 degrees, according to equation number 1, equals to y over x. I will repeat again. In triangle AEC, tangent 80 degrees equals to y over x. Here we will multiply equation number 1 by x, and we will get that according to equation number 1, y equals to x times tangent 80 degrees. In the next step, we will focus on the right triangle, triangle AED. On the right triangle, triangle AED, we know that here, before that, we will define the angle that we are looking for, that is to say angle ADC as theta. So in the right triangle, triangle ADE, we know that sinus theta equals to AE over AD. I will repeat again. In the right triangle, triangle AED, we know that sinus theta equals to AE over AD. But we know that AE equals to Y and AD equals to A. So actually, in conclusion, we actually found out that according to equation number 2, sinus theta equals to y over a. I will repeat again. According to equation number 2, sinus theta equals to y over a. Here we will multiply equation number 2 by a, and then we will divide it by sinus theta, and we will get that according to equation number 2, a equals to y over sinus theta. But according to equation number 1, we know that y equals to x times 80 degrees, so a will be equal to y, that is x times 80 degrees, over sinus theta. Okay, in the next step we will focus on the right triangle, triangle AEB. On the right triangle, triangle AEB, tangents 30 degrees. I repeat again. On the right triangle, triangle AEB, tangents 30 degrees will be equal to AE over BE. Tangents 30 degrees equals to AE over BE. But AE equals to y according to our definition, and BE equals to a plus x. So actually, according to equation number 3, tangent 30 degrees equals to y over a plus x. I will repeat again. According to equation number 3, tangent 30 degrees equals to y over a plus x. So we know that y equals to x tangent 80 degrees, and a equals to x tangent 80 degrees over sinus theta. So we will substitute y and a by their values from equation number 1 and equation number 2, and we will get that according to equation number 3, tangent 30 degrees equals to y is x tangent 80 degrees according to equation number 1 over a plus x, and a according to equation number 2 equals to x tangent 80 degrees over sinus theta, and we also must add x. We will add x, but we will multiply x by sinus theta, and then we will divide x by sinus theta, so we will change nothing. So here we will move sinus theta from the denominator to the numerator, and we will get that according to equation number 3, tangent 30 degrees equals to x tangent 80 degrees times sinus theta divided by x tangent 80 degrees plus x times sinus theta. So here we have x in the denominator and we have x in the numerator, so x will get cancelled. And what is left from equation number 3 after we cancelled x? First of all, we also know that tangent 30 degrees is equal to 1 over square root of 3 units, so I write it down. According to equation number 3, tangent 30 degrees is 1 over square root of 3 units, and it equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sinus theta. So here we will cross multiply this equation number 3, and we will get that according to equation number 3, 1 over square root of 3 equals to, so we cross multiply the equation number 3, so it is actually tangents 80 degrees plus sinus theta equals to square root of 3 times tangent 80 degrees plus square root of 3 times tangent 80 degrees times sinus theta. Here we will subtract sinus theta from this equation number 3, and we will get that tangent 80 degrees equals to square root of 3 times tangent theta times tangent 80 degrees times sinus theta minus sinus theta. So here we will subtract sinus theta from this equation, equation number 3, and we will get that tangent 80 degrees equals to here we subtract sinus theta from this equation, equation number 3. In the next step we will take sinus theta as a common factor from this expression. So sinus theta is a common factor, and inside the brackets we will have from this expression is square root of 3 times tangent 80 degrees, and we took from sinus theta from minus sinus theta as a common factor. So what is left from minus sinus theta is minus 1. So here we will divide this equation, equation number 3, by square root of 3 times tangent 80 degrees minus 1, and we will get that sinus theta equals to tangent 80 degrees over square root of 3 times tangent 80 degrees minus 1. So here we will substitute tangent 80 degrees by sine 80 degrees over cosine 80 degrees, and we will get that tangent sinus theta equals to tangent 80 degrees is sinus 80 degrees over cosine 80 degrees, divided by square root of 3, and again tangent 80 degrees is sinus 80 degrees over cosinus 80 degrees, and we have also to subtract 1, so we'll substitute 1 by minus cosine 80 degrees over cosine 80 degrees, that is actually 1. Here we have cosine 80 degrees on the numerator, and we have cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled. And what is left from equation number 3 after we cancelled cosine 80 degrees? What is left? It is actually in this side we have sinus theta that equals to sinus 80 degrees over square root of 3 times sinus 80 degrees minus cosine 80 degrees. So here we will multiply the denominator on this side of equation number 3 by 2, and then we will divide it by 2, and we will get that sinus theta equals to sinus 80 degrees over, so we will multiply the denominator by 2, and then we will divide it by 2. So to 3 over 2 times sine 80 degrees so it is here minus cosine 80 degrees over 2 So according to equation number 3, we got that sinus theta equals to sinus 80 degrees over 2 times sinus 80 degrees, and we will substitute square root of 3 over 2 by cosine 30 degrees, because cosine 30 degrees equals to square root of 3 over 2 minus, we will substitute 1 over 2 by sinus 30 degrees, so it is actually sinus 30 degrees times cosine 80 degrees. So we got that sinus theta equals to sinus 80 degrees over 2, actually sinus 80 degrees times cosine 30 degrees minus sinus 30 degrees times cosine 80 degrees is very similar to the trigonometric identity that states that sine A times cosine B minus sine B times cosine A equals to sine A minus B. So according to this trigonometric identity, we can substitute our expression by sine A minus B, when A equals to 80 degrees and B equals to 30 degrees. So we will substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So in conclusion, we found out that sine theta equals to sine 80 degrees over 2 sine 80 degrees minus 30 degrees. 80 degrees minus 30 degrees is 50 degrees, so I will write it down. We'll get that sinus theta, according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sinus, and 80 degrees minus 30 degrees is 50 degrees. And we will use the trigonometric identity that states that sinus 2a equals to 2 sine A cosine A. So actually, according to this trigonometric identity, we will get that sinus 80 degrees equals to 2 sine 40 degrees cosine 40 degrees. So we substituted sinus 80 degrees by 2 sine 40 degrees times cosine 40 degrees, and then we have to divide it by 2 sine 50 degrees. Two over 2 is 1, so 2 will get cancelled. Then we will use the trigonometric identity that states that sine alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that sine 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sine 50 degrees equals to cosine 90 degrees minus 50 degrees is cosine 40 degrees. 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. That is to say, we can substitute sine 50 degrees in this equation number 3, by cosine 40 degrees, because sine 50 degrees equals to cosine 40 degrees. So we'll do it now, and we will get that according to equation number 3, sine theta equals to sine 40 degrees times cosine 40 degrees, and we will substitute sine 50 degrees by cosine 40 degrees, so it will be over cosine 40 degrees. So here we have cosine 40 degrees in the numerator, and we have cosine 40 degrees in the denominator, so cosine 40 degrees will get cancelled, and we found out that sine theta equals to sine 40 degrees. If sine theta equals to sine 40 degrees, it means that theta equals to 40 degrees. So we found out that theta equals to 40 degrees. That is to say, the angle that we are looking for, that is angle ADC, that equals to theta, equals actually to 40 degrees. So we can write here that it equals to 40 degrees. So the angle that we are looking for, that is actually angle ADC, equals to 40 degrees. We found out that the angle that we are looking for, that is angle ADC, equals to 40 degrees. So in both methods, we found out that the angle that we are looking for is equal to 40 degrees. In the next step, I will summarize the lecture. Actually, we found the value of angle ADC in two different methods. In the first method, we define side AC as A, we define side BC as B, and it is given us the question that AD equals to BC, but according to our definition, BC equals to B. So from this equation, AD equals to BC equals to B, we will derive that AD equals also to B. So AD equals to B. Then I presented to you the law of sines. The law of sines is true in any triangle. So if we have this triangle ABC, that could be any triangle. And we know that side AB equals to C units, side AC equals to B units, and side BC equals to A units. This is angle A, this is angle B, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. Okay, so from this equation, from this formula, we will derive that A over sine A equals to B over sine B. Then we implemented the law of sines in our triangle ABC. So I copied triangle ABC in a new page. This is triangle ABC. We know that angle BAC equals to 50. Actually, we know that angle ABC equals to 30 degrees. Angle ACB equals to 100 degrees. And this angle is the missing angle. So we defined it as angle x, and we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle x plus 100 degrees plus 30 degrees must be equal to 180 degrees. Here we subtracted 130 degrees from this equation, and we found out that angle x equals to 180 degrees minus 130 degrees is 50 degrees. So angle BAC equals to 50 degrees. Then we implemented the law of sines in this triangle, triangle ABC. According to the law of sines, A over sine 30 degrees equals to B over sine 50 degrees. Here we divided equation number 1 by B, and then we multiplied by sine 30 degrees. And we got that A over B, according to equation number 1, A over B equals to sine 30 degrees over sine 50 degrees. Then we focused on triangle ADC. But first of all, we found out that this angle BAC equals to 50 degrees. So if we define angle BAD, this angle is theta, then angle DAC, this angle will be equal to 50 degrees minus theta. So angle DAC equals to 50 degrees minus theta. Angle ACB equals to 100 degrees, it is given us in the question. And this angle is defined as angle Y. It is the missing angle. It is the angle that we are looking for. And according to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that this angle, that is angle Y, plus this angle that equals to 100 degrees, plus this angle that is 50 degrees minus theta must be equal to 180 degrees. Here we subtracted 150 degrees from this equation, and we found out that angle Y minus theta equals to 180 degrees minus 150 degrees is 30 degrees. So, and then we added to this equation theta, and we got that angle Y equals to 30 degrees plus theta. So this angle, that is the angle that we are looking for, equals to 30 degrees plus theta. Angle ADC equals to 30 degrees plus theta. Then I copied this triangle ADC in a new page, and we implemented the law of sines in this triangle ADC. So this is triangle ADC, angle DAC equals to 50 degrees minus theta, angle ADC equals to 30 degrees plus theta, and the angle ACD, it is given us that it equals to 100 degrees. We implemented the law of sines in this triangle ADC. According to the law of sines, we will get that A over sinus 30 degrees plus theta equals to B over sinus 100 degrees. Here we divided equation number 2 by B, and then we multiplied by sinus 30 degrees plus theta, and we got that A over B equals to sinus 30 degrees plus theta over sinus 100 degrees. And according to equation number 1, A over B equals to sinus 30 degrees over sinus 50 degrees. Then we created equation number 3 that states that A over B according to equation number 1 must be equal to A over B according to equation number 2. And A over B according to equation number 1 is sinus 30 degrees over sinus 50 degrees, and it must be equal to A over B according to equation number 2, that is actually sinus 30 degrees plus theta over sinus 100 degrees. Here we cross multiplied this equation number 3. We know that sinus 30 degrees is 1 over 2, so we will get that 1 over 2 times sinus 100 degrees equals to sinus 50 degrees times sinus 30 degrees plus theta. And we use the trigonometric identity that states that sinus 2a equals to 2 sine a cosine a. So according to this trigonometric identity, we will get that sine 100 degrees equals to 2 sine 50 degrees times cosine 50 degrees, that equals to sine 50 degrees times sine 30 degrees plus theta. Here 2 over 2 is 1, so 2 will get cancelled, and we have sinus 50 degrees in both sides of the equation of number 3. So sine 50 degrees will get cancelled, and we left only with cosine 50 degrees, that equals to sine 30 degrees plus theta. And according to the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, we will get that the value of cosine 50 degrees will be equal to sine 90 degrees minus 50 degrees. That is to say, the value of cosine 50 degrees it is sine 40 degrees, because 90 degrees minus 50 degrees is 50 degrees. So we found out that cosine 50 degrees equals to sine 40 degrees. Therefore, we can substitute cosine 50 degrees in equation number 3 by sine 40 degrees. We did it, and we got that sine 40 degrees equals to sine 30 degrees plus alpha. That is to say 40 degrees equals to 30 degrees plus theta. We subtracted 30 degrees from this equation, and we found out that angle theta equals to 40 degrees minus 30 degrees is 10 degrees. We found out that angle theta equals to 10 degrees, but the angle that we are looking for is angle ADC that equals to 30 degrees plus theta. That is to say, angle ADC that equals to 30 degrees plus theta will be equal to 40 degrees because of the fact that angle theta equals to 10 degrees. So angle ADC equals to 30 degrees plus 10 degrees. That is to say, the value of angle ADC is equal to 40 degrees. Then I presented to you how to find out the value of angle theta according to the second method. In the second method, we actually defined side BC as A, and we know that AD equals to BC, but according to our definition, BC equals to A. So from this equation, AD equals to BC equals to A, we will derive that AD also equals to A. Then we extended side BC by a straight line, and from point A we drew perpendicular to the extended BC, and we defined the intersection point between the perpendicular from point A and the extended BC as point E. We defined side AE as Y and side CE as X. Then we found out the value of this angle that we defined as angle Y. We know that BC is one side of a triangle ABC, therefore it is absolutely a straight line. And then when we extended the straight line BC by a straight line, we got line segment BE that will be still a straight line. So we found out that line segment BE is a straight line, and we have the rule that the sum of the angles on one side of a straight line will be equal to 180 degrees. I repeat again, we found out that line segment BE is a straight line, and according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. If we focus on the upper side of the straight line BE at point C, the sum of the angles must be equal to 180 degrees. That is to say, 100 degrees plus this angle, that is angle Y, must be equal to 180 degrees according to the rule that I mentioned. I will repeat again, 100 degrees plus angle Y must be equal to 180 degrees. Here we subtracted 100 degrees from this equation, and we found out that angle Y equals to 180 degrees minus 100 degrees is 80 degrees. So we found out that this angle ACE equals to 80 degrees. Then we focused on the right triangle, triangle ACE. On the right triangle, triangle ACE, we know that triangle 80 degrees equals to AE over CE. In the right triangle, triangle ACE, we know that triangle 80 degrees equals to AE over CE. AE equals to Y, CE equals to X according to our definition. So actually we found out that triangle 80 degrees in triangle AEC equals to Y over X. Here we multiplied equation number 1 by X, and we found out that Y equals to X times triangle 80 degrees. Then we focused on the right triangle, triangle ADE. We defined angle ADE as theta, that is the angle that we are looking for, and we know that sinus theta in triangle ADE will be equal to AE over AD. Okay, in the right triangle, triangle AED, we know that sinus theta equals to AE over AD, but AE equals to Y according to our definition, and AD equals to A according to what we have already found. That is to say, we found out that according to equation number 2, sinus theta equals to Y over A. Then we multiplied equation number 2 by 1, we multiplied the equation number 2 by a and divided by sinus theta, and we found out that a equals to y over sinus theta. But according to equation number 1, y equals to x times tangent 80 degrees. Therefore, sinus theta, therefore a that equals to y over sinus theta, and y equals to x times 80 degrees. So we'll substitute y by x times 80 degrees, and we will get that a equals to x times 80 degrees over sinus theta. And according to equation 1, y equals to x times tangent 80 degrees. Then we focus on the right triangle ABE. On the right triangle ABE, we know that tangent 30 degrees equals to AE over BE. Tangent 30 degrees equals to AE over BE, but AE equals to y, and BE equals to A plus X. So therefore we found out actually that tangent 30 degrees equals to y over A plus X, and y equals to x times 80 degrees. A equals to x times tangent 80 degrees over sinus theta. Okay, so actually we substituted y by x times tangent 80 degrees, and we substituted a by x tangent 80 degrees over sinus theta, and we also must add x, and we actually added x, we multiplied x by sinus theta, and then we divided by sinus theta in order to have a common factor with this expression. So in conclusion, we found out that tangent 30 degrees equals to x times 80 degrees over x times tangent 80 degrees plus x sinus theta over sinus theta. Here we moved sinus theta from the denominator to the numerator, and we got that tangent 30 degrees equals to x times tangent 80 degrees times sinus theta over x tangent theta plus x sinus theta. Here we have x in the numerator, and we have x in the denominator also, so x will get cancelled. And we also know that tangent 30 degrees equals to 1 over square root of 3 units. So in conclusion, we found out that according to equation number 3, tangent 30 degrees is 1 over square root of 3 units, and it equals to tangent 80 degrees times sinus theta over tangent 80 degrees plus sine theta. Here we cross multiply the equation number 3, and we got that tangent 80 degrees plus sinus theta equals to square root of tangent 80 degrees times sinus theta. Here we subtract the sinus theta from this equation number 3, and we got that tangent 80 degrees equals to square root of 3 times tangent 80 degrees times sinus theta minus sinus theta. In the next step, we took sinus theta as a common factor from this side of equation number 3, and we got to the equation that tangent 80 degrees equals to sinus theta, so sinus theta was taken out as a common factor, and inside the brackets we left with square root of 3 times tangent 80 degrees minus 1. Then we divided this equation number 3 by square root of 3 times tangent 80 degrees minus 1, and we got that sinus theta equals to tangent 80 degrees over square root of tangent 80 degrees minus 1. Then we substituted tangent 80 degrees by sinus 80 degrees over cosinus 80 degrees. So tangent 80 degrees equals to sinus 80 degrees over cosinus 80 degrees, and we also have to divide it by square root of tangent 80 degrees, but tangent 80 degrees is sinus 80 degrees over cosine 80 degrees, and we also must to subtract 1, but we substituted 1 by minus cosine 80 degrees over cosine 80 degrees in order to have a common factor with this expression. Here we have cosine 80 degrees in the numerator, and we have also cosine 80 degrees in the denominator, so cosine 80 degrees will get cancelled, and we got to equation number 3 that states that sine 80 degrees equals to sine theta equals to sine 80 degrees over square root of 3 times sine 80 degrees minus cosine 80 degrees. Here we multiplied the denominator by 2 and then we divided by 2. So we got the equation number 3 that states that sine theta equals to sine 80 degrees over 2. And in the brackets we have square root of 3 over 2 times sine theta minus cosine 80 degrees over 2. So we actually multiplied the denominator by 2 and then we divided by 2. So we changed nothing. Then we actually got here we substituted square root of 3 over 2 by cosine 30 degrees and we substituted 1 over 2 by sine 30 degrees. Okay, and we got the equation number 3 that states that sine 80 degrees equals to 2 times sine 30 degrees, and instead of square root of 3 over 2 we have here cosine 30 degrees, and here we have minus, instead of minus 1 over 2 we have minus 30 degrees times cosine 80 degrees. Actually this expression is very similar to the trigonometric identity that states that sine A cosine B minus sine B cosine A equals to sine A minus B. It means that we can substitute our expression by sine A minus B when A equals to 80 degrees and B equals to 30 degrees. So we did it in the next step, and we got that sine 80 degrees equals to sine theta equals to sine 80 degrees over 2 times sine A is 80 degrees and B is 30 degrees. So we got in the denominator that is 2 times sine 80 degrees minus 30 degrees. Then we know that 80 degrees minus 30 degrees is 50 degrees. So in the next step we found out that according to equation number 3, sinus theta equals to sinus 80 degrees over 2 times sine 50 degrees. Then we use the trigonometric identity that states that sinus 2a equals to 2 sine A cosine A in order to treat sine 80 degrees. So according to this trigonometric identity, we will get that the value of sine 80 degrees is 2 sine 40 degrees times cosine 40 degrees. So in conclusion we got that sine theta equals to 2 sine 40 degrees cosine 40 degrees over 2 sine 50 degrees. And then we use the trigonometric identity that states that sinus alpha equals to cosine 90 degrees minus alpha. According to this trigonometric identity, we will get that the value of sinus 50 degrees equals to cosine 90 degrees minus 50 degrees. That is to say, sinus 50 degrees equals to cosine 90 degrees minus 50 degrees is 40 degrees. So we found out that sine 50 degrees equals to cosine 40 degrees. Therefore, we can substitute sine 50 degrees in the denominator of equation number 3 by cosine 40 degrees. So we did it here. And we got that sinus theta equals to sine 40 degrees times cosine 40 degrees. And as I already told you, we substituted sine 50 degrees by cosine 40 degrees. So here we have cosine 40 degrees in the numerator and we have cosine 40 degrees in the denominator. So cosine 40 degrees will get cancelled. And we left only with sine theta that equals to sine 40 degrees. Sine theta equals to sine 40 degrees means that theta equals to 40 degrees. That is to say, the angle that we are looking for, that is actually angle ADC that equals to angle theta equals to 40 degrees. So we found out that the angle that we are looking for, angle ADC, equals to 40 degrees. And in both methods, we found out that the value of angle ADC equals to 40 degrees. Okay, thank you very much.